Astronomy is one of the vastest and most complex fields of science. The word itself comes from Greek and means the science that studies the laws of stars. When we think about human nature, one of the primary principles is our quest for knowledge. We're constantly trying to solve what is unknown, and perhaps the oldest example of this is the simple act of looking up at the night sky and wondering what's up there. This question has been around ever since the dawn of time, and some of it has been answered, while some of it is yet to be. Astronomy is one of the vastest and oldest fields of science. Just for perspective of how old astronomy is, it is believed to have begun in the Mesopotamian era, which was roughly 6,000 years ago. Due to the sheer size of a subject like this, it's important to go over the right things at the right time, or else things can get really confusing. And so this video is going to be about giving ourselves a sense of scale in terms of the universe, and showing how insignificant we really are. To begin our scale, we'll use a human that is 2 meters tall. So if this person were to lay on the ground, 10 times the person's length would be around the length of an 18-wheeler, which is around 20 meters. If 100 18-wheelers were to line up end to end, the total length would be around that of the Golden Gate Bridge. The Golden Gate Bridge, 10 times over, would be roughly the size of a large city, such as San Francisco, as we can see here in this satellite image. So as we can now see, we're starting to get bigger and bigger at an exponential rate, but we're still nowhere near where we want to be. So let's keep going. So if a city that's roughly 20 kilometers long were to be duplicated 10 times and lined up, we start to see significant parts of a country. For example, we can now see the entire San Francisco Bay Area in this satellite image. If we multiply by 10 again, we can see a big chunk of Western America. We have several states such as California, Nevada, Arizona, New Mexico, and Oregon. So we're already past the distance at which we humans are used to operating with. If we were to naturally travel across a span of land like this without the use of technology, it would take ages. So now if we take this Western American square and multiply it by 10, we would get a little bit over the diameter of the Earth. So for the vast majority of humans, our entire lives occur over this span of area, as there's very few of us who have actually exited our home planet. We're already past the ability of which our minds can grasp the size of things at this scale, but we'll keep going further. If we multiply the Earth's diameter, which is 12,700 kilometers, we would get the diameter of Jupiter, which is the largest planet in our solar system. This is the first thing that I would say is far beyond our comprehension. Considering how vast the Earth already is, Jupiter has a diameter 10 times that, and a volume that is way more than even that. But let's keep going. 10 times Jupiter's diameter would now be the diameter of the Sun. So we're on the scale of stars now, which is incomprehensible for sure now. Stars are huge celestial bodies made mostly of hydrogen and helium that produce light and heat from churning nuclear forges inside their cores, and so to imagine the sheer size of these things would be impossible. When we multiply the diameter of the Sun by 100, we get the distance from the Earth to the Sun, which is known as an astronomical unit, or AU for short. You may or may not have heard that the light from the Sun takes roughly 8 minutes to get to Earth, which means it's 8 light minutes away. The speed of light is the fastest thing in the universe, as many of you know, and it travels at just under 300,000 kilometers per second. This means that an astronomical unit is just under 150 million kilometers long. However, to get to the nearest star, we would need to multiply the distance from the Earth to the Sun by 200,000. The closest star to our solar system is Proxima Centauri, and it's 4.2 light years away. This means that light, which goes 300,000 kilometers per second, will still take 4.2 years to get from our Sun to Proxima Centauri. This distance can also be equated to 200,000 astronomical units. So our scale is now so immense that our unit of measurement is the distance that it takes light a year to travel. Our next step of the scale is the galactic scale. Our very own galaxy, which is the Milky Way, is 25,000 times larger than the distance from the Sun to the nearest star, which means that the Milky Way has a diameter of roughly 100,000 light years. In this image that we see here, each pixel has several stars in it, but each star is still separated by several light years of emptiness. So this means that there are hundreds of millions of stars in our galaxy, most of which have their own planetary system, which is why some people believe that alien life must exist somewhere, and this is all only in one galaxy. The final skill that we'll look at for today is the observable universe itself. Since it's theorized that the Big Bang occurred 13.8 billion years ago, which we'll go very deep into in the future, it is theoretically possible that the observable universe is 93 billion light years across. Anything past that we can't see because the light from the start of the Big Bang has still not reached there. So to get to this unfathomable number, we would have to multiply our Milky Way galaxy's diameter, which is 100,000 light years, by a grand total of 1 million times to get to the universe's diameter. It's estimated that there are approximately 2 trillion galaxies in the observable universe alone. So now that we've hit the last level of the universal scale that is theoretically possible at the moment, the immediate question is what's past that? The universe might be larger than 93 billion light years, and it might even be infinite. Nobody knows. It's just one of the hundreds of questions that people have been wondering for thousands of years, which is one of the main components that makes astronomy so interesting. The fact that there's so much to learn, and also so much that we still don't know, and might not ever know. So through the entirety of this video, we've learned that not only are we astronomically insignificant, but the things that we build are small. Our planet is small. Our star is small. Our interplanetary system is small. And now even our entire galaxy is all just a grain of sand in the universe's desert. Now that we have a sense of scale of the things we're working with in this field, we can now go about getting into the finer details of everything that there is to know, and how they come to be. But for now, I thank you all for watching.